So this is actually the last topic in week 20 that comes up naturally if you just go along as it told you to. Now, if you're going into this section here and you're changing things, there may very well be other topics in there. But if you're just naturally following it the way that Alex is asking you to follow it, this should be the last topic that it comes up for you. Because this would, especially mean absolute deviation, which is the one that came right before this one, and then population standard deviation. Those are two more involved calculations for this week. By involved, I just mean there's more steps. Doesn't mean that they're very difficult, just means there's more steps. So let's take a look at this one, population standard deviation. So we did mean absolute deviation on another video. So we heard the word absolute. That tells us we're going to deal with absolute values. When we hear population standard deviation, it actually means we're going to deal with squaring numbers and then taking square roots of the number at the end. So it's a little easier if you can relate those two. So when you hear absolute deviation, you're taking the absolute value. Standard deviation means we're going to be doing squares and square roots. All right, so we have 5 participants in a 200-meter dash had the following finish times in seconds. So here are the 5 finish times for these 5 participants. And assuming that these times constitute an entire population, find the standard deviation of the population, round your answer to 2 decimal places. So again, if you don't know the definition of any of these blue words, you are welcome to click on them. It opens them up. So in this case, population just means if we have 5 participants that are in a 200-meter dash, then population would be all the people that were participating in that 200-meter dash. That would be the population. In this case, we only looked at the 5 participants instead of all of them, but we're saying that they represent the whole population. Standard deviation, which we're going to talk about how to do that down here. So the definition would just give you another example of exactly what it's going to give us to write down here. And then round your answer to 2 decimal places. So for whatever, instead of saying round to the nearest hundredth, they are saying round to 2 decimal places. So same idea as rounding to 100th. All right. So we're told that those 5 times constitute a population, and we're asked to find the standard deviation of this population. The calculation for standard deviation of a population is slightly different from the calculation for the standard deviation of a sample. So we didn't do standard deviation of a sample. They're just letting you know that it is slightly different. So the standard deviation, this is the, is that the deviation symbol? That symbol, that's bad, that's a Greek symbol. That name is escaping me for just the moment, of a population is the measure of the spread, which actually, yes, okay, so that is standard deviation, comes right after that, okay. Is the measure of the spread of the measurements of the population about their mean, and this is the symbol for mean. So these are just Greek symbols, and they tend to use them in the calculations instead of writing out standard deviation and mean, they'll just write this symbol instead. The more that the measurement tends to differ or deviate from their mean, the greater the standard deviation. So when we did the absolute mean deviation, or sorry, mean absolute deviation, that just told us how far away in general, just points away, they were from the average. In this case, we're also going to find the average, the mean. So the same calculation first, you add the numbers and divide by the number of numbers you have. Sounds a little funny, but so we have 5 numbers, we add them together and divide by 5, we get 28. Instead of using absolute value in this one, what we want to do is we're still going to subtract the number from the mean. So the first number here is 26, and they're subtracting 28. But then we square it. So we square each one. So we have 26 minus 28, and then whatever we get here, we square. 25 minus 28, and then we square it again. 31 minus 28, we square it again. So we're going to subtract the number from the mean each time, just like we did in the last one. But this time we're going to square each number. This actually also takes care of that pesky negative sign, but for a different reason. That's not why we square it, but that's kind of a nice feature there too, is it does take care of that, that negative sign for us. So once they get to the end, they're not telling you what each one of these equals. So they just skipped ahead and they told you if you do all these calculations, you get 42, and then you're going to divide by 5 again, because that's how many numbers you have here. So this is one number, this is one number, this is one number, this is one number, and this is one number. So it's 5 different numbers. So if you do 42 divided by 5, you get, and they're actually not showing you, I want to do it real quick, 42 divided by 5, we get 8.4. The last step we have to do is the square root of this number. So if you turn your calculator, let's see. I'm going to do my calculator on my computer real quick. So if I have 8.4 on my calculator, I can hit this little square root button here. So the x under the square root, and then it has a 2. Sometimes the 2 is not there. If there's no number there at all, it is assumed that it is a 2. So I hit square root, and that is where they got 2.9 because they rounded. So they had rounded up. So it said 2 decimal places, but if I go 2 decimal places, that's 9. And if I go one more to the 8, then the 8's going to round the 9 up to 10. Well, if I round up to 10, then that actually rounds this 9 up to 9, or this 8 up to 9, sorry. So that's why they have here 2.90, because we can't write 2.810. That wouldn't be the same number. So that's how they do that. And then this is the general formula. So the formula looks quite a bit more complicated than the actual calculation because they're using a lot of those Greek symbols. Like that big E-looking symbol is the symbol for sum, and so it's just a way to say that you're adding up all the squares. So let's see. I think we are ready to go ahead and get started. Okay, so our first step is, it says the ages and years of 5 employees at a particular computer store are the following. So we have 42 plus 43 plus 25 plus 42 plus 23. So here are our 5 numbers. So we want to add our 5 numbers up. So we have 42 plus 43 plus 25 plus 42 plus 23. And I show that I get 175. I'm going to confirm it real quick. I always double check this, especially when it's multiple numbers, because you could have accidentally typed the wrong number in, and that would mess up the whole calculation all the way down. All right, so I do get 175, and I'm going to divide by 5, and I get 35. So this is my average. Average is just kind of like where would kind of the middle be of the numbers. It's not a perfect middle, but it's the average of the range more than of each range more than it is the actual middle. All right, so now what we need to do is take the difference. I'm going to do this one in red. So each number, we're going to go, I'm going to start with 42 because it's my first number, and I'm going to subtract 35. And I get 7. Then I'm going to square it, and I get 49. So I'm going to do this for each number. 43 minus 35, and I get 8. And I'm going to square that, and I get 64. Whoa, 64. And then 25 minus 35, and I do get negative 10 on this one. But once I square it, it just becomes 100 because negative 10 times negative 10 is positive 100. 42 minus 35. So I've already done this one. This was the first one we did. We get 7 squared, which is 49. And then 23 minus 35. I get, let's see, what is that? 10, 11, 12. Negative 12 squared, and I get 144. All right, so I have 5 new numbers here. So I want to add 49, 64, 149. Woo! For some reason, my pen does not like that forward. So 49 and 144. We are going to divide all this by 5 again. So we get 49 plus 64 plus 100 plus 49 plus 144. All right, so I get 406 divided by 5. I'm going to make sure before I calculate. Plus 64 plus 100 plus 49 plus 44. Okay, so I do get 146. I'm going to open my calculator back up here, I think. All right, so if I type in 406 and I divide by 5, here's the decimal I get, but I'm not done. Remember, with this one, you have to take the square root. So we get, I'll write this one in black here, so we get 9.0111. It said go 2 decimal places, so that's this first one here. So I'm going to take a look at the number right after it. It's just a 1, so that's 4 less. So the numbers all past that just kind of drop off. So I'm just going to have 9.01. So 9.01. We're going to check. And ta-da! We got it right. So our standard deviation, which we do learn more about this as we move forward, because it has to do with when we start drawing bell curves for this. There's a certain deviation step outs for each time you do this calculation, because you can do this more than once. So the first standard deviation for this population, which is a little different because we're doing population instead of sample, but this deviation is generally about 9 points. All right, so let's go ahead and go next. I'm going to erase this. And all right, so we have 5 quiz scores of a student in a statistics course. Each quiz was graded on a 10-point scale. So assuming these scores constitute an entire population, so again, if it's an entire population, these are only 5 of the quiz scores for this student. Well, they could have taken 10 quizzes, they could have taken 15 quizzes. We don't know how many quizzes they took total. These are just 5 of the quizzes that they're telling us. And they're telling us that this constitutes an entire population, meaning that it's a good sample. So it's a good range of numbers. It's pretty common range of numbers, I'll say it that way. 6 plus 9 plus 8. All right, so our first step is to add all of these numbers together and then divide by 5 since we have 5 quizzes. So we have 7 plus 10 plus 6 plus 9 plus 8. So I end up with 40. Add it one more time just to make sure. Yep. So we end up with 40 divided by 5, which is 8. All right. So now, and I'm going to switch my pen color again here. All right, so now we're going to take each number and we're going to subtract from the mean. So I'm going to start with 7 and I'm going to subtract 8. And I end up with -1 squared. -1 squared is just 1. Then I go 10 minus 8. I end up with 2 squared is 4. 6 minus 8, I end up with negative 2, which is still 4, because negative 2 squared is the same thing as 2 squared, because two negatives make a positive. All right, 9 minus 8, I end up with 1 squared, which is 1. And 8 minus 8, I end up with 0. 0 squared is 0. All right, so here are my 5 new numbers. 1, 2, 3, 4, 5. So I'm going to go 1 plus 4 plus 4 plus 1 plus 0 divided by 5. So we end up with 5, 10 divided by 5. So, and this way I just did this mental math because they're small. So I did 4 and 5, 4 and 5. 5 plus 5 is 10. So I end up with 2. At this point, I'm going to grab my calculator again real quick. So make sure you clear that out. So 10 divided by 5 is 2. And make sure you hit the square root button. So if you don't hit the square root button, then we haven't quite got the full answer here. So I know some of the students were forgetting that simple last step of just make sure you hit the square root button. So we want to round to 2 decimal places. So that 1, we look at the 4 or less, it just drops off and we just leave it the way it is. So this is going to be 1.41. So the last one was 9 points away for the standard deviation. This is only 1.4. So it's actually clustered much closer together. So this number tells you how spread out they are. That's what this does. And deviation just tells you how if you have a plan and you deviate from the plan, it's kind of like you're changing it. You're going a different direction, something like that. So this is the same idea as deviate means how far away from the average did the numbers land. So the smaller the deviation, the closer the numbers are clustered. All right, one last one, and then we should be all finished up with week 20. Whew, won't that be nice? Okay. So this is the ages and years of the 5 doctors at a local clinic are the following. So we have 33 plus 40 plus 40 plus 52 plus 55. We're going to divide by 5. All right, so we have 33 plus 40 plus 40 plus 52 plus 55 equals 220 divided by 5. Again, super great idea to add them up again, and I just got a different number. So wait, 33 plus 40 plus 40 plus 52 plus 55. Okay, so I got 220 again. But I didn't run the second time. All right, divided by 5, we get 44. So I'm going to go and change this. So now each number, I'm going to start with 33 minus 44, and I get negative 11 squared, which is 121. And then I get 40 minus 44, which is negative 4 squared, which is 16. You get the same number again because there's 2 40s in a row, so I'm just going to be a little lazy and write 16 there. Skip to 52 minus 44. We get 6, 7, 8 squared, and we get 64. And then 55 minus 44. And I get 11 on that side, but this time is positive 11. But it doesn't matter. Negative 11 squared and positive 11 squared get you the same answer because 2 negatives make a positive and 2 positives will stay positive. All right, so I have 121 plus 16 plus 16 plus 64 plus 121 divided by 5 plus 16 plus 16 plus 64, 120, whoops. All right, so I end up with 338 divided by 5. So 121, 121 plus 16, 16 plus 4 plus. Okay, and I was just confirming real quick that it is in fact 338. All right, I'm going to flip over to my calculator again real quick here. So we have it just typed in. So our 338 divided by 5. So I get 67.6. Don't forget to hit the square root button because your answer is not the 60 number. So 2, 1. All right, so we went around to the second number after the decimal. So I'm looking at the 1. Since it's a 1, just drops off, and we just type in 8.22. And we check. Ta-da! And hopefully, as long as you kind of followed through, I believe this should be your last topic for week 20. So good job.